Sometimes it is necessary to change the data type of a variable. There are two ways to accomplish this change, using implicit and explicit data conversion. Although we already talked about the fact that Java is a strictly data type language and it is really important to declare each variable with a specific data type, the type of data stored at that variable name can be changed both temporarily and permanently using something called implicit and explicit conversion. An implicit conversion occurs when an equation has more than one data type, such as an integer and a double. The computer must decide which data type to use for the result of the equation. Implicit conversions always use the largest data type from the equation. For example, if you multiply 10 times 15.75, the result should be 157.50. We automatically know that we want to include the fractional portion of our result. Another good example of this situation is probably finding the average of a group of numbers. If the numbers are integers, you still want to make sure to get the fractional portion of the result. If we wanted to find the average of 3, 5, and 8, we would add them together and divide by 3, which would result in 5.33 repeating. When programming, the computer chooses the resulting data type based on the values in the equation. So if you want to include a fractional portion, at least one value must have a decimal point. In this case, we would rewrite our equation as 3 plus 5 plus 8 divided by 3.0. Now let's talk about explicit conversion. Explicit conversion allows the programmer to have control over the variable data by casting the variable with a new data type. For example, to find the average of 3 integer values, we can change the data type to a double for the sum of the numbers. So here you can see I have the word double in parentheses in front of the part of the equation that adds 3, 5, and 8. This will change the result to a double. Then we divide that value by 3, and the result is a double, and we don't lose any precision. Now this is what we call a temporary conversion. The values of 3, 5, and 8 are temporarily converted to a double, so when we divide by 3, we don't lose any precision. Now let's try this in NetBeans to help clarify these concepts. I already created a data conversion project folder, and in the dataconversion.java program, I'm going to go ahead and show you what would happen when we do the examples from the PowerPoint. So let's add system.out.println, and let's go ahead and print out the result of adding 3 plus 5 plus 8 and dividing that by 3. Put a semicolon at the end of our statement, and right below that, let's show the difference if we did the exact same equation, but this time, let's go ahead and do 3 plus 5 plus 8 divided by 3.0. Okay, in the second equation, we should get the decimal portion of our answer. In the first equation, we won't see that. Let's go ahead and run this. You can see the first equation on line 16 gave us the result of 5. That's because 3, 5, 8 added up to an integer, and when you divide it by an integer, you only get the integer portion of your result. The second line, because I included a double, it automatically widened the result to include the decimal portion. So I got 5.33 repeating. This concept is really important when we start to use equations such as the volume of a sphere. Let's go ahead and do that. Right below my two system.out.printlns, I'm going to add an equation. I'm going to say double volume equals. We know the volume of a sphere is 4/3, so 4 divided by 3, times pi. I'm going to go ahead and use the math library, so I'm going to do math.pi, and then I'm going to multiply that times the radius cubed. I'm going to go ahead and put a radius of 10, so I'm going to do 10 times 10 times 10. Okay, so right now I calculated the volume. Let's print it out. The volume of a sphere with radius 10 is, and I want to add volume. Okay, we need a semicolon at the end. I'm going to comment the first two lines out since we're not using those right now. And let's go ahead and run our program. Okay, we see that the volume of a sphere with a radius of 10 is 3,141.59, etc. Okay, it gave us a decimal point because math.pi is a double, but the problem is that is not the correct value. Let me show you. I'm going to go ahead and add a second variable. I'll call it real volume, is equal to 4 divided by 3.0 times math.pi times 10 times 10 times 10. Notice the only thing I changed here was the 3 to a 3.0. Now I'm going to go ahead and print this value out right below the first one. Okay, I kind of ran out of room, but I can always put the plus sign and hit enter, and I can put my next variable name down the second line with my semicolon. Okay, this time when I run the program, it's going to print out both the first volume and what I'm calling the real volume. Okay, notice if you used a calculator, you would find that 4/3 times pi times 10 cubed is really 4,188.79, etc. Do you see what a difference that made? So it's very important that you remember that if you divide two integers, you're only going to get the integer portion of that result. One more common mistake that I see often in introductory programming courses is calculating Celsius from a Fahrenheit temperature. Celsius is equal to Fahrenheit minus 32 times 5 divided by 9. Since 5 divided by 9 returns an integer value of 0, the answer is always 0. Let me show you that calculation. If I create a value for Fahrenheit and I set it equal to 212, and then I go ahead and print out the result of Celsius, you'll see that when I run this, the value of Celsius is going to be 0, because this equation here, 5 divided by 9, is always 0. Even if I change Fahrenheit to any value, let's change it to 500 and try it again, it is still 0. The good news is that all of these problems can be solved easily by using implicit conversion. So if I change my 5 divided by 9 to include a decimal, 5 divided by 9.0, because it does not change the value, and I run it again, you can see I'm getting the correct Celsius value. In Java, the IDE does not allow you to use implicit conversion when assigning a double value to an integer variable. This is called a narrowing condition and can cause data loss. The only way to accomplish this task is to use explicit conversion.